My name is Francis Clegg, and I'm the current treasurer of the Clay Minerals Group, which is a special interest group of the Mineralogical Society of the UK and Ireland. The Clay Mineral Group was founded in 1947, so this means this year we celebrate a Jubilee anniversary for 75 years of continued research exploring the wonderful world of clays and clay minerals. This year, 2022, we are celebrating this achievement through several activities and events, including a series of 12 interviews highlighting the diversity of minds and hearts behind the amazing world of clay mineral research and application. In this interview, it is my utmost pleasure to introduce and interview Kirill Shafran. So, Kirill was born and studied as a chemist in Odessa, Ukraine. He did a PhD degree in inorganic materials chemistry at Nottingham Trent University, and that was with Professor Carol Perry in 2003. This was followed by 2 postdoctoral positions at the same university. He then joined Unilever Research and Development, Port Sunlight in the UK in 2006 as a research chemist and worked for nearly 10 years until in 2015 when he moved to BYK Additives in Widnes, UK. Currently, he leads a research program on new synthetic minerals that are predominantly clay-based materials. So welcome, Kirill.
Thank you. Thank you for having me, Francis.
Okay. So it's really great to see you and be here, and it's a privilege to be able to interview you. My first question is about your route to being a clay chemist or clay scientist. There are many ways and entry points to clay science. So how did this come about for you?
Well, to start with, I don't claim to be a clay scientist per se. My background is in chemistry, but what brings me, into clay science is the need for knowledge about clays, which we are trying to learn from nature, how to make them on industrially feasible scales. So. Clay science is really paramount for me and my team, and that's why I'm trying to be involved in this really fascinating area. Okay,
so being inspired by nature to design new synthetic clays, it's a really nice concept. We certainly do have a lot to learn from Mother Nature, definitely. So how were you introduced to the world of clay? Did anybody inspire you to get involved?
In my previous work and experience, I've known about clays, but never really engaged closely with these materials. And when I joined BYK in 2015 as a research chemist, I've been introduced to this fascinating world, and my first teachers about clays were my managers, Jane Doyle and Dave Shaw, and they really helped me discover this work and gave me a great grounding in this fascinating subject. And of course, later on, I tried to join the clay science community, the wider clay science community. And it's a close-knit community, but through participating in conferences, I got to know quite a few people there. And this community is very welcoming for new members, fortunately for me. So also, I really appreciate the help and learnings from my colleagues who I've collaborated with, the colleagues in Aberdeen, in Krakow, in Granada, in Bayreuth. They all kind of taught me something about clays, and I managed to, I think, master a little bit this subject in the last few years.
Excellent. It's good to hear that the clay community is a welcoming community. Yes, definitely.
It is. Very much so.
So my next question is about current interests. What is your current interests in clays?
Well, as a team, we are concerned with producing these synthetic clays, which one could call designer clays. And we are trying to do it with as wide variety of technological applications as possible. And as you know, within BYK, we have both synthetic and natural clay products. And there are so many different real-life applications for them, both existing and potential. So our flagship group of products comes under the trademark of Laponite, and it's quite an old material which has been very successful for several decades, both commercially and in academia. Lots of interest in academia, and of course, to avoid turning this material into commodity chemical, we have renewed our efforts as a company to try to expand the range of materials that we can produce, make new Laponite grades, but also beyond that marvelous material. So there are so many interesting emerging markets for clays, and things like barrier coatings, for instance, catalysis, energy storage, advanced formulations, biomedical applications, and so on. And you know, for biomedical applications, Laponite is particularly probably useful because it's a natural mimetic material and it's very benign. So you will see a literal explosion of literature on Laponite being used in biomedical field recently.
Okay. I don't want to put you on the spot, but would you be willing to stick your neck out and state which of these new and interesting emerging markets you were particularly excited about?
You know, we are interested in all of these, but my personal excitement comes from biomedical applications, because we already offer some synthetic products in the Laponite range for things like, for instance, making hand sanitizing gels. Very important issue now. And you can structure with Laponite alcohols and even the hypochlorous acid solutions. We also see reports about Laponite being used in much more advanced applications like regenerative medicine, you know, tissue engineering, and even there are papers about obesity treatment with Laponite. So really fascinating and cutting edge stuff there. So that's my personal kind of choice.
Oh, that's really nice, really nice. Okay, so I'll move on to the next question. So there are many areas of clay research. What do you think are the big clay research questions that still need to be answered?
Yeah, I think clay science is really, it has matured obviously, but after so many decades, not centuries of research, we still have quite a few fundamental questions unanswered, you know, about clays, because they are great materials, but quite complex systems from many points of view. And I think one of the great questions that we pose today, how can we leverage the tremendous technological potential of clay materials? Because you often see in industry perception of clays as niche materials, and we know, you know, from inside that you can do so much more than just a very specific application, and also do things in quite cost-effective manner. And I think that there's so much work ahead, you know, for scientists, engineers, and technologists to realize that tremendous technological potential. That's one kind of challenge. But more fundamental level, one of the questions we always ask, you know, how can we predict behavior of clay platelets in dispersed state in water, for instance, especially in complex systems like modern day industrial formulations, which contain many components. And of course, Laponite as a material has been a model and a tool for academia and industry to actually study these dispersed systems in a great amount of detail. And it resulted in a lot of fascinating applications, even outside of industry. Um, and we know that clay science can be used for many things, like controlling landslides, for instance, storing nuclear waste, or even understanding Martian soils. I hope that studies on a simple Lapanite system helped a little bit, understanding those systems a little bit better. So still, these are such multifaceted and complex systems, clay minerals and their dispersions. I think we still need to work on to complete the picture about these materials. And one thing that particularly interests and concerns me is how we can control the parameters of clay products better, that the products that we produce or are going to produce. And we're talking about things like size, charge of clay platelets, how we can control it with more precision, almost at atomic level. We're thinking and working in this direction. And if you think of Lapanite, it's only 25 nanometers wide and 1 nanometer thick. But it gives these particular parameters, give it tremendous rheological power, for instance, the ability to thicken aqueous formulation, and lots of other fascinating properties that other clays might not necessarily have. And finally, okay, if we've learned to control the properties of clays, how these properties are linked with specific applications, how they translate into better applications. And this is something we are working on a lot at BYK. And we engage with the wider clay science community on these topics and try to learn and discuss these things.
Excellent. There are a lot of challenges there for us to consider and ponder upon, and certainly things to inspire and think about as we conduct our own research. I like the idea of looking at the atomistic level, which then controls the shape of the clay and its properties, and then also linking that to the application as well. All those three facets are really important for our research. Yeah, so something to think about. Something we can let our minds explore, and perhaps while we reflect and relax in our hot bath in an evening, something to wonder about. Excellent, that's really good.
Agreed.
So moving on to the next question. So the world is experiencing many challenges. Which global challenges do you think clay science can help to address?
Well, we all know the main challenges facing humanity today. It's climate, energy, environment, and maybe health. Well, maybe exactly health. I strongly believe, and I'm sure clay scientists with me, that clay materials can contribute to solving all of these challenges.
Could you give some specific examples?
Sure. For instance, if we start with the energy, for instance, we know that Lapanite has been proposed for structuring the solvent part of lithium batteries, making them more efficient. So that helps energy. In terms of environment, we are working to replace a plastic packaging with the more recyclable version, and barrier properties of clay materials could play a significant role here. In terms of health, I already mentioned biomedical applications of Lapanite and related materials in areas like tissue nanoimaging, regenerative medicine, tissue engineering, and so on. Also, hazardous substances and pollutants can be extracted using natural and synthetic clays very efficiently. So we can help a lot. And finally, of course, climate. And here, I would like to mention our drive as a company in BYK to be carbon neutral. We're planning to do it by 2025 as the latest. There's a huge drive for that and very ambitious sustainability plans. And of course, as you know, clay, synthesizing clays is an energy intensive process. So to try and reduce the energy and make the process more sustainable, that's what we work on with our engineers today as well. So we can contribute to all of these important topics and global challenges.
Okay. Yeah, thanks. These examples really do show the versatility of the clays. Yeah, I like the use of clays also, helping us to live healthier lives for longer as well. It's really important for our aging population. Okay. Okay, so next question is, what is the proudest moment or the time when you had the greatest satisfaction or the best clear decision of your research or career?
Wow, I'm not sure about decisions, but my greatest satisfaction is seeing clay products that I helped to design, making it to large-scale production and to the market. This would be my greatest satisfaction. We are still in the process of reaching some of these goals, but this is something to look forward to, and it's very, very satisfying for industrial scientists like myself.
No, yeah, that's really impressive. There's someone who's interested in applied research. That's an impressive achievement. How could you give an indication of how long that process took from maybe concept to the lab and then to industrial applications and commercialization?
I would say maybe several years on average. It's hard to say. It depends on how novel the technology is. Is it incremental change or it's a dramatically new development that changes the time scale? But the process is always the same. We come up with the concept, prove the principle in the lab, in our R&D center here, and then the scale up it follows and commercialization after that. So in scale up, we need to work with our engineers to very closely to ensure a scalability of our materials from the start. And with our market specialists, we need to work on the ways to commercialize these exciting new products that we have in the pipeline. So yeah, it takes a few years, but it's a tough process, but it really kind of is satisfying to see the fruit of your labor, if you will, and see a large scale production of the material that you helped to develop.
Yeah, I think that makes it even more impressive, the fact that it's done over a large time scale. Yeah, so you need persistence and as well as the dedicated team that you have around you as well. Yeah, that's really good. Okay, all right. I think this is a tough question, but we were asking it of most of the people that we interview, and it's always important to remember in research that research doesn't always go to plan. Can you give us your perspective on work that has failed to produce the results that you had hoped for?
I think that the examples will be too many. I think that our path as scientists, both in academia and industry, is paved with failures. But having said that, I think there is a fundamental difference between industry and academia, that in industry, we prefer to fail fast and move on quickly to a new idea, new angle to attack a problem from a different point of view. And this is kind of the trait that you learn when you work to certain timelines and have this additional pressure. Yeah, I think it's normal to fail, and we can learn from our failures.
Yeah, no, I'm probably guilty of not moving on too fast after a mistake, but it's a learning curve, isn't it? I suppose the learning curve is important, and how well rapidly one bounces back from that failure. Yeah.
I agree. And you know, sometimes negative results can tell us more about process or about uh, system we are studying than a bunch of positive results. So they're useful. They're really useful. Um, and also, you know, they talk a lot about serendipity, the importance of serendipity in the discovery process. And if you think of it, you know, those serendipitous discoveries probably at some point were no more than a failed experiment.
That's right. That's true. We'd certainly definitely have to learn from our mistakes. Yeah, that's good. Okay, thank you. So next question, what is your favourite clay and why?
I think for me it would be Laponite still. You know, if clay is a wonder material, then Laponite is a wonder of wonders. Uh, you can play almost endlessly with its form and properties. You can devise completely new and fascinating applications with it. Its versatility is a premium, and as well as purity, um, especially comparing to the natural counterparts. And it's great for both the industrial applications and for model studies in academia. So really love that material.
Yeah, I have to agree. It is a special clay, and especially for the applied clay scientists, with its many uses and future potential uses as well. Yeah, yeah, I have to agree with you to some extent there.
Thanks.
So next question. So there will be students and early career researchers listening to this interview. What advice would you give to those starting a career in clay science, or perhaps even to your 20-year-old self?
Well, from my own experience, Francis, I've become an industrial scientist almost by chance, through a combination of circumstances. But after nearly 17 years in industry, I realized that I really enjoy this setting and I enjoy it to a full extent now. I think the greatest thing about working in industry, if for someone that wants to pursue this path, is that you can see results of your work in action. I'm not sure you can see behind me, there is a plant that produces laponite every day. And this actually encourages us to really focus on our day-to-day work and try to design things quicker and better to make them happen on that plant. And if people are thinking of taking an industrial path in their career, I would recommend, uh, you know, to build their mental resilience and the ability to work under pressure. And of course, especially towards the later stages of career, the soft skills, you know, so much talked about, things like communication, self-organization, teamwork, networking, they are really helping together with the hard skills that we learn, you know, from professionally and from experience. So that really helps, especially, you know, when the career matures.
That's very sage advice. And you missed part of the question. What would you particularly say to your 20-year-old self?
I thought long about this question, Francis, and I think what I would say to myself at 20 years old would be to explore different options when you choose a career path. Try to see different things, you know, screen them early and see for yourself what you really want to do. And also the fact that any knowledge is never wasted. One day it will work for you. I can explain that because I've been working in different areas of chemistry, you know, analytical chemistry, inorganic chemistry, materials chemistry. And today I'm doing clay science, also applied clay science. And all of those, pieces of knowledge that I've accumulated in my long career actually are clicking now, and working together in a quite nice way. And I appreciate that breadth, not only depth, but breadth of background that I was fortunate to achieve. So that's my advice, maybe to my 20 years old self.
No, I like that advice. That's really good. Thank you. Thank you very much for that. Okay, so there is a world outside clays. When you're not working on clays, what do you like to do?
Thank you for that question, Francis. I've been trying lately to lead a more balanced life, and not very successfully, to be honest. So I'd like to spend more time with my family. I have wife and two children, aged 19 and 23. And I also love reading all sorts of books, things like sci-fi, history, fiction, and listen to all sorts of music. Most of all, I like exploring with my wife, walking kind of around the local area where I live, on the Wirral, which is a very lovely and beautiful area. And I also a little bit thankful, it's a silver lining from COVID era that we are hopefully coming to an end of. Um, we were bound to the British shores during these 2 years, and we managed to explore quite a bit of Britain, and we found so many places with outstanding beauty and so much diversity. Highland Scotland and the east and west coast of England, Wales, beautiful places. So that's kind of thing I really like most.
Okay, I think you should work for the UK Tourist Board. I agree. The UK countryside has got a lot to offer. Okay. Just a point to note that the sun has now stopped shining through your window, and we can now see the plant where the lapinite is made. So that's very fortunate. We can now see where that's being made. Okay. So
that's where magic happens. Yeah.
And that's another thing that the UK has: mixed weather. We always have that. Yeah. So this is my last question. Who is your clay hero or heroine? And who would you want to interview?
Francis, I think my biggest hero would be Dr. Barbara Neumann. She is an inventor of lapinite, and I think she was an exceptional lady and an amazing scientist. For me, it's an example when you can get out of your comfort zone. She was a physicist by training, mineralogist, and she embarked on this epic journey of discovering lapinite and other synthetic clays, out of this vision or idea that she could mimic or replace a naturally occurring mineral, say hectorite, with the synthetic version of it, which wasn't, it was only a nascent field at the time. And she succeeded on a great scale. Not only is she managed to patent the best, probably one of the best processes possible for this, but in a couple of years after the patenting, there was already production running, and she contributed enormously to that as well. And she didn't stop after patenting and scaling up. She continued to develop new minerals, find new uses for them. She learned this new field of rheology, controlling the flow of liquids and effectively controlling the structuring of liquids. And yeah, she's done so much. And when I read, I wasn't personally, I never met her in person, but when I read her reports, which are beautifully written, very precise, very clear, very ambitious in scope, I just I feel like I know this person, at least the professionally, I know a little bit about her. And as you know, we've established an award in Mineralogical Society named after Barbara Neumann to recognize the fact that she was an important industrial clay scientist, and she contributed through the discovery of lapidine and other technologies to clay science quite a lot. And I'm so thankful to Clay Mineralogy Group that was the driving force behind that. And I'm really glad that happened. It's well deserved. We shouldn't forget our heroes, and she's one of heroes that should not be forgotten.
Okay, no, that's true. We should also mention at this point the recent article, which was published in Clay Minerals 2020, or the abridged version in Elements. It's all about Barbara Neumann and her life and history. It's a good read, so I definitely recommend you read that, and especially if you're looking for inspiration too. Okay. So this concludes our interview. I would like to thank you very, very much, Kirill, for taking the time and to take part in our series of interviews with different clay scientists. And this is being held because of the Clay Minerals Group Jubilee celebrations. And,
well, it's been a privilege, and thank you for the opportunity also to talk to you, Francis.
And hopefully we've inspired the future clay scientists that will be celebrating in another 75 years. Okay, so thank you very much.
Thank you.